Pretty much every piece of modern AI. We're talking ChatGPT, image generators, you name it. It all runs on one single revolutionary idea. It's a concept called the attention mechanism. And it's basically how we taught machines not just to read data, but to actually focus on what really matters.
So, think about this. How does an AI remember that tiny, crucial detail from Chapter 1 when it's all the way in Chapter 30 trying to solve the big mystery? Well, for the older AI models, this was a massive problem. They had this critical bottleneck. You could almost call it a kind of digital short-term memory loss. It made connecting ideas across long distances practically impossible.
And here's why. This really shows the fundamental difference. On the left, you've got the old way. Models like RNNs would try to cram the entire story, everything that came before, into one single compressed memory slot. Imagine trying to summarize a whole novel into just one sentence, right? You're going to lose a ton of critical details. But the new model, the one with attention, it's completely different. It keeps the entire book open, and it can look back at any word from any page at any time with perfect clarity. Nothing gets lost.
Okay, to really make this click, let's use an analogy. Imagine the AI is a researcher standing in a gigantic library. To find the exact piece of information it needs, it uses this really clever three-part system. First up, we have the query. For every single word the AI is looking at, it basically forms a question. So if it's processing the word it, the query is kind of like the AI asking itself, what noun in this sentence could it possibly be referring to? It's the active search, the thing it's looking for. Next up, keys. Now, every word in the sentence also has a key. Think of these like the labels on the spine of all the books in our library. The key for the word animal, for instance, might say something like, hey, I'm a singular noun, I'm a living thing. It's basically advertising what kind of information it holds. And finally, we have the values. This is the good stuff. This is the actual information inside the books. It's the rich, meaningful content of each word. So while the key is the label on the outside, the value is the full story on the inside. The word's full definition, its essence. You can think of it as this rich, numerical fingerprint that captures all of that word's different meanings and connections.
Okay, so we've got our query, our keys, and our values. The real magic happens in how these three things talk to each other. It all comes down to a simple but incredibly powerful four-step recipe for finding meaning.
So here's how it works. First, the model takes the query and compares it to every single key in a sentence. This gives it a relevance score. A high score means, hey, this is a strong match. Second, it normalizes those scores using a function called softmax. That's just a fancy way of saying it turns all those raw scores into clean percentages that add up perfectly to 100%. Third, it takes those percentages, those attention weights, and multiplies them by the actual values. The real substance of the words. And finally, it just adds all of that up to create a brand new package of information that is now deeply, deeply aware of its most relevant context. And what's just wild is that this entire powerful process can be captured in this one, single, really elegant formula. This equation comes straight out of the groundbreaking 2017 paper that literally changed everything. It was called perfectly, Attention is All You Need, and it introduced the transformer architecture that powers AI today. Now, theory is one thing, but let's look at some real examples to see why this is such a game changer. This is where it really clicks.
All right, take the phrase American shrew mole. Here the word mole obviously means a small burrowing animal, right? The attention mechanism figures this out because the query for mole gets a super high relevance score from the keys attached to American and shrew. It pays attention to its neighbors.
But what about in the phrase 1 mole of carbon dioxide? Now the exact same word, mole, means something completely different. Attention allows the model to basically ignore the biological context and instead focus on the words 1 and carbon dioxide, letting it correctly figure out we're talking about a unit of measurement in chemistry. And one more for good measure, take a biopsy of the mole. The context of biopsy immediately tells the model to focus on a medical definition. You see? Without the ability to weigh the importance of these surrounding words, the model would be completely lost. Attention is what gives it that focus.
This whole process also works within a single sentence, which we call self-attention. Check this out. The animal didn't cross the street because it was too tired. When the model gets to the word it, its query instantly finds a strong match with the key for animal, not for street. And just like that, it learns to link the pronoun to the correct noun, solving that ambiguity in a split second.
So you can see, this wasn't just a small improvement. This was a complete paradigm shift. It changed the entire field of AI.
So why was it such a revolution? Well, it boils down to three huge things. First, it solved that long-term memory problem. The technical term is the vanishing gradient problem. Attention creates direct shortcuts to any word anywhere in the text, so nothing gets forgotten. Second, it's massively parallel. Instead of processing words one by one, attention can look at all the words at the same time. This is perfect for modern GPUs, and it's what allows these models to get so gigantic. And third, it's interpretable. We can actually look under the hood and visualize what the model is paying attention to when it makes a decision, which is incredible.
So just how important is attention to these models? Get this. In the GPT-3 model alone, nearly 58 trillion parameters, those are the model's building blocks, are dedicated just to its attention mechanisms. It's not just some feature, it is the absolute heart of the machine.
So, by giving machines the ability to focus, we didn't just make them a little bit better, we unlocked a totally new level of understanding. And the question that leaves us with is pretty exciting. As this ability to pay attention gets even more powerful, what subtle patterns and new connections will AI start to notice next? What will they see that we've been missing all along? Thanks for tuning in.